Hello, my name is Fuyuki Ishikawa from National Institute of Informatics. So let me introduce the formal specification series is a top SE program. So we are operating the lectures with uh, a lecturer from Japanese Space Agency, Sony, and a company that is selling the proof techniques for safety critical or reliable software. So I'm not sure. I don't think you are familiar with the formal specification techniques. So I'm showing the image of a specification done in VDM language. So it's a rigorous description of the specification, and then we can use intensive verification techniques given this kind of machine processable description. You may feel it's like a program, but it's a different because we want to specify the specification of the software systems or even design of software systems. So it's much more abstract compared with the program code, but it is rigorous. Or you can say it's a formal. So that's a formal specification techniques. So this kind of techniques is useful to eliminate the first problems caused by ambiguity of specification or design that typically occur with natural language. And we can so we can expect the efficiency and quality by detecting the defect in early phases when we give some specification documents or design documents. Of course, we can think of a strong verification of programs, but basically we focus on usage in the early phases because checking Japanese documents or even in English or in whatever natural language document is hard because we need to be careful about many aspects. And it highly depends on the reviewers. And this kind of machine processable description will also help enhance various activities such as testing because many activities in the development process depend on the specification. So I'm showing how the techniques is used. So the common process is we start with natural language documents, but it actually contains the inconsistency or ambiguity. So we make a formal specification in this way, so make it rigorous. And while in this modeling, we abstract away implementation details, so that's quite different from program coding. And the important thing is to clarify key constraints or what the code must satisfy before we make the code actually. So that's the specification. Then we have a machine processable formal description with clear semantics. Then we can use various kinds of verification techniques. So we can run a simulator of this kind of specification to do testing. We may do mathematical theorem proving to give strong assurance. Or we can even generate examples that satisfy the specification. Sometimes, of course, we have multiple levels of documents. For example, specification and design. Then we want to check the consistency between the high-level document and lower-level document. That is also possible, called refinement checking. So after improving the content, removing the ambiguity, this result may be feedback to the original natural language document. But it is notable, so some companies only use this modeling language for the specification rather than using the ambiguity in the natural language documents. So actually, we can find several advanced applications of this kind of technique. In Japan, it's very famous for that Felica or Sony Felica chip used this kind of technique. So it's a chip for e-money chip inside the smartphones and cars. So there are millions of applications. So this company rigorously specified by using this kind of formal specification language and use the testing to test to check their external specification. So the chip specification to be used by many chip providers and partners. So the quality of this specification is very important for Sony Felica. And it is reported they excluded bugs caused by description issues. So another example is this is also famous railways in Paris and actually others, worldwide. So they rather depend on more mathematical proofs, and they took an approach called correctness by construction. So they use stepwise refinement. So they have some specification model, then they check the correctness by mathematical proof. Then they make it more concrete, close to code, and then check the consistency. So by repeating that process, we can obtain the code already correct for the specification. So this is the new way of development for the very safety critical domain. So of course, many students in the top SC program applied this kind of techniques inside the top SC exercises. So many people tried this kind of technique in their specific domains, and sometimes chips, sometimes cloud, or so some people actually tried to use this kind of language when outsourcing to, for example, Vietnam or China, because using Japanese or English is hard anyway. And so some people also use, machine processable aspect of this kind of language to automate testing activities. And actually, it's notable that some people also tried use of this kind of language to model the real world. So they try to formalize to make a model of the business rules, such as calculation of the metro fees, or interestingly, tickets of Tokyo Disneyland. It's a little bit complex mechanism. And we provide the course structure to learn this. Actually, this kind of technique is new to many people who did not learn computer science in the university. That is typical. So we start with theory, mathematical theory of program verification, and we use the actually simplest language, VDM, to make an introduction to the formal specification techniques. Then students can choose different lecture classes. So if they like more practical exercises, we have such a lecture. But we also provide lecture classes for more strong verification techniques, stepwise construction of correctness assured system models, or using more mathematical strong theorem proving tool. We also have a workshop style lecture to discuss how to make use of this kind of technique, or even improve natural language communication and documents. So in summary, so this is a formal specification series, and we teach rigorous modeling and verification of the specification and design documents. What we learn is actually abstract modeling, and especially rigorous one of what, excluding how to implement. And we also learn how to verify the correctness of such models. Of course, this is necessary if you want to use formal specification techniques directly. But I strongly believe this by learning this kind of thing, even if you don't use the formal specification techniques directly, you can make use of the knowledge because it serves as the foundation for various issues of, for example, separating what and how, tackling ambiguity issues, and different verification approaches to the correctness. So that's all. Thank you so much.